This is the beginning of our statistics unit. Statistics is really analyzing a lot of numbers in a certain way. Here we're going to be talking about graphs mostly and how to answer questions based on graphs and maybe how to find the mean, median, mode of graphs, comparing and analyzing different ones. But really, statistics is used in science and politics and really a lot of different fields because basically all it is analyzing a lot of different numbers like survey results or an experiment. The first graph we're going to talk about here is a scatter plot, and that's basically just a relation between any two variables. It's sometimes a function. Like we talked about before, a relation could be a function as long as the x values don't repeat. We'll see that a scatter plot could be a relation or a function. Really, it's mostly just relations, and it's represented as a graph. A correlation is really an essential part of a scatter plot. It tells us the trend in whatever information we're talking about. It tells us the relationship or the connection between any two variables, and it's a number as opposed to the graph. We can see three different types of correlations here. A positive correlation means as one variable increases, the other one also will increase. It also could work the other way. As one variable decreases, the other variable does the same thing, it decreases. So it's important that they do the same thing. So in this first example, time and distance traveled in a race are positively correlated because as the time increases in a race, the distance should increase in the race. So as this number increases, as our x value increases, this example is going 2 miles an hour. As our time goes on, our distance increases, we see a positive slope, an uphill slope going from left to right. That's a positive correlation because as the time increases, as these numbers get bigger, so do these numbers which represent the distance. So the time and distance both increase at a rate of 2 miles per hour. That's the rate of change or the slope for this graph. The second example we see here is no correlation, where the two variables have nothing to do with each other. They do not affect each other. So one example is the hours of sleep you get per night and the number of times you've been outside the country. Those really don't have anything to do with each other. As the hours of sleep you get per night increases for some people, the number of times they've been out of the country could increase, it could decrease. It really has nothing to do with each other. Those are two variables that really don't affect each other. So in that case, we'd see a bunch of scattered points like this. This really means that we can't really predict how many times someone has been out of the country based on their number of hours of sleep. Really, if they had, let's say, an average of 10 hours per sleep, they could have gone out of the country twice, or they could have gone out of the country 8 times. It's really unpredictable. We don't see sort of trend like we do in this example. The next example is a negative correlation. That means as one variable increases, the other one is actually going to decrease. So they're going to do opposite things. So this example is the number of hours of video games and the number of hours of homework. So as your video game hours increase, your hours of homework have to decrease. In this example, we're starting off with 8 hours of homework and 0 hours of video games. As you start spending more time on video games, it limits the amount of time that you can spend on homework. In this example, we're spending 8 hours on homework and 0 hours on video games. At this example, at that point, we're spending 8 hours on video games and 0 hours on homework. That's a negative correlation because we can see that is going downhill. That is a negative slope there. Alright, so we're going to use the scatter plot to the left to answer the questions. How many oil changes per year would a person have if they spent $300 on an engine repair? So let's look at the graph. We have number of oil changes per year at the bottom and engine repair costs going up. So this is some number of oil changes that we get versus the engine repair costs. And we can see that this is going downhill. That has a negative correlation. And this line that we see going through this is the line of best fit, or a trend line. It's basically just an estimation of the middle of all of these points. It's just trying to cut through as many points as possible. It doesn't necessarily have to hit a lot of points. It just needs to go through the middle of most of these points, just through the middle, the general middle of the scattering of points. We're actually going to use that to figure out these questions. So how many oil changes per year would a person have if they spent $300 on engine repairs? So engine repairs is over here. This is $300. We're just going to trace a line. I'm going to draw a little dotted line going from 300 to our trend line, or to our line of best fit. That's about where it is. and then draw a line down to the number of oil changes to figure out what it's going to be on the x-axis. So our cost, or our y, is $300, and this dotted line seems to line up pretty directly with the 5 oil changes per year. So that's telling us that we're going to get 5 oil changes per year. We're going to work backwards from what we did on this previous one on letter B. If a person had 7 oil changes per year, how much would they pay for an engine repair? So this is the second set of dotted lines. We have 7 oil changes, that's our x. We're going to follow that up to our trend line, and then follow that across to our y coordinate. That seems like that's a little bit above 150, maybe it's 175. Let's just say in between 150 and 200, somewhere in between there. We're really looking for an estimate. On a multiple choice question, obviously you'd pick the answer that's in between those if they're being specific. Alright, so this one's a little bit different. Again, we're going to use a scatter plot to answer the questions, but we don't have a trend line on this one, so we kind of have to draw that for ourselves. And then we're going to answer these questions. We're really just asked to estimate, based on either an x-coordinate or a y-coordinate, what's the other coordinate going to be. So this is the trend line I drew. It's really just a sketch. It's just trying to go through as much of the middle of those scattered points as possible. So you can kind of see how I'm already answering those 3 questions. I'm just going to walk through those. How many calories are in a sandwich that contains 17 grams of fat? So our fat, that is our x-coordinate. That's at 17. That's just past 15 here. So I drew a dotted line up to my trend line, and that hit at about 450. Again, we're just looking for an estimate. If you're ever asked a question like this, they should give you a range here. It might say 460, it might say 440. My trend line's not perfect, but you need to be able to estimate it pretty clearly. I mean, you should be able to rule out answers like 500, 600, 700. So on my trend line, that seemed to line up with 450 the best. On the second one, how many grams of fat are in a sandwich that has 600 calories? So this one, we're looking at the calories. We're looking at 600. Drew my dotted line straight over to my line of best fit, and then trace that back down to the x-coordinate. That looks like it lines up perfectly with 30. So our y-coordinate was 600. We followed that to just the middle of that scattering of points, and trace that back down to the x-coordinate of 30. Estimate how many calories the sandwich would have with 20 grams of fat. So again, we're looking at the x-coordinate now. We're looking directly at 20, and that lines up with 500 as a y-coordinate, and that's the number of calories.